Part 1. Please find a quiet place to sit or lie and to listen to this audio. Once seated or lying, close your eyes. Focus your attention on your breath. When you are ready, inhale slowly. Let the air fill your lungs. And then exhale slowly. Let the air escape from your lungs. Inhale again, and then exhale again. Notice how your stomach rises as you inhale and falls as you exhale. Rises as you inhale and falls as you exhale. If your mind wanders, don't be concerned. Just gradually shift your attention back to my voice. Part 2. Now imagine you are sitting or lying by a stream, with the warm but gentle sun bathing your face. The water in this stream cascades over some rocks and meanders around thick, lofty trees. Occasionally you notice some leaves drifting aimlessly down the stream. Now become aware of the thoughts, images and memories that pop into your head. Imagine that each thought, image or memory is written on one of the leaves you see. For example, if you experience the thought, "This exercise seems strange," imagine these words are written on one leaf. If you remember a friend or relative from your past, imagine a picture of this person appearing on the leaf. Then allow these leaves to drift away with your thoughts, images and memories. Don't worry if occasionally you're distracted. Just return to this image of the leaves vanishing into the distance. Part 3. Now shift your attention to your quadriceps, the muscle between the knee and the hip on the top of your legs. Imagine that somehow you can actually see this muscle a few centimeters inside your skin. And imagine this muscle is composed of many long red fibers that almost stretch from your knee to your hip. When you zoom closer to examine this muscle, you notice the muscle is not only composed of these fibers. On the muscle are a few other cells that resemble long oval band-aids or bandages. These cells, these long oval band-aids or bandages, are called muscle spindles. As you imagine these band-aids, repeat the term muscle spindles, muscle spindles, muscle spindles. So what is the role of these muscle spindles, these band-aids or bandages, and how do these muscle spindles work? Well, to answer this question, imagine for a moment that someone bangs your shin with a hammer or pulls your foot backwards suddenly behind your body very vigorously. Both of these events would actually stretch your quadriceps, the muscle between the knee and the hip, very harshly and suddenly. Yet, as soon as someone bangs your shin with a hammer or pulls your foot backwards vigorously, your knee suddenly straightens, sometimes called the knee-jerk reflex. So to understand why, gently focus your attention again on the muscle fibers of your quadriceps and the muscle spindle that seems to be attached to a few of these fibers. Now in slow motion, imagine the muscle stretch vigorously when struck with a hammer. Watch the fibers of this muscle stretch as well, and observe the muscle spindle extend too, like a stretched band-aid or bandage. Part 4. You then notice an axon, like a long cord, extend from the muscle spindle all the way to the bottom half of your spinal cord. And this axon ends near another cell body located inside the spinal cord. You notice that another cord or axon emanates from this cell body in the spinal cord and travels back to the muscle fibers in your quadriceps. Now imagine again that the muscle spindle stretches as your shin is struck with a hammer. As the muscle spindle stretches, visualize an action potential like a spark of energy travelling along the axon or cord that extends to the spinal cord. Perhaps you can hear a hissing sound as this spark of energy reaches the spinal cord. And then as soon as this spark of energy reaches the spinal cord, notice the adjoining cell body also send a spark of energy back to the muscle fibre along an axon. Imagine this action potential or spark of energy travel from the spinal cord back to the quadriceps. And then, once the spark of energy reaches the muscle, the fibre contracts or shortens. As the muscle fibre contracts and the quadriceps shorten abruptly, the leg actually straightens instantly for a moment, like a kick. Now replay these events briefly in your mind. As the muscle stretches suddenly, the muscle spindle extends rapidly, like stretching a band-aid or bandage. An action potential or spark of energy then travels from this spindle to the spinal cord and then back to the muscle. And the muscle then contracts, offsetting the initial stretch. So this contraction is designed to offset the initial stretch and therefore can protect the muscle. If the axons or spinal cord was damaged, this reflex might be impeded, so the muscle would not contract when stretched suddenly. Instead, the muscle might tear. The muscle would not be protected. Part 5. So you realise that muscle spindles protect muscles from extreme or vigorous stretching, but then you wonder whether something else might protect muscles from vigorous contractions. For example, imagine that lying on the floor is a dumbbell or weight. The dumbbell looks very heavy as a human perhaps. Imagine that you've decided you want to raise this dumbbell. You prepare to raise the dumbbell towards your shoulder, bending your arm at the elbow as forcefully as you can. But after you completed this movement, you realised the dumbbell was not heavy at all. Unfortunately, this revelation was too late. You had already raised the barbell too vigorously. You had contracted your bicep, the muscle between your elbow and shoulder at the top of your arm, just too forcefully. You worry that perhaps these forceful contractions might have damaged the muscle fibres. That is, you're concerned that your muscle fibres might have shattered with the force in which you lifted the dumbbell. But for some reason, the muscle fibres seem intact. Your muscle feels good. Fortunately, in your tendons, the tissue that connects the muscle to the bone is a special cell or receptor called a Golgi organ. You can perhaps visualize this Golgi organ as like a tiny little goalie diving to save a goal, attached to this tendon between the muscle and the bones. As you maintain this image, repeat the word Golgi organ, Golgi organ, Golgi organ. Whenever the muscle contracts and shortens suddenly, the tendon is actually pulled or extended vigorously. So for a moment, while your bicep contracts or shortens abruptly, you can hear the tendon groan in pain when stretched unexpectedly. And consequently, this tiny goalie, this Golgi organ, is also stretched forcefully. Part 6. After the Golgi organ stretches, a sequence of action potentials are evoked. Specifically, an action potential like a spark of energy travels from the Golgi organ along an axon that extends to the spinal cord. As soon as this spark of energy reaches the spinal cord, an adjoining cell body also spends a spark of energy back to the muscle fibre. So imagine this action potential or spark of energy travel from the spinal cord back to the bicep. So what is the effect of this action potential back to the bicep? Well, this spark of energy actually inhibits the muscle fibres and thus impedes contractions. So the muscle therefore does not contract as vigorously as you planned. The muscle is thus protected. Now replay these events briefly in your mind. As the muscle contracts vigorously, a Golgi organ embedded within the tendon also stretches suddenly. An action potential or spark of energy then travels from this Golgi organ to the spinal cord and then back to the muscle. The muscle is inhibited, offsetting the original contraction. The muscle therefore does not contract too wildly.